you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T here, and I want to go through the solutions to our first Conics translation assignment that you've worked on. Question 1 in the assignment, you were supposed to write down the formulas or the templates for the conics when they are centered somewhere other than the origin and show both the horizontal and vertical form. Now earlier in our unit, when we did the conics the first time around, we had already done the circle centered somewhere else, and there is no horizontal or vertical, so they're the same. And remember, the ellipse, we had x over a squared, y over b squared equals 1. So the only thing that changes is the center of the ellipse. We now replace x with x minus h and y with y minus k in both forms. And again, with the ellipses, the bigger number, if it's under x squared, is horizontal, and if the bigger number is under the y squared, it's vertical. So for ellipses, the a squared is always the bigger of the two numbers. For hyperbola, it's based on what's positive, so either the x is positive or the y. Again, it's x minus h and y minus k replacing the y's, and same with the parabola. So it's all the same formulas that we used the first time around. We're just replacing every x with x minus h and every y with y minus k. So if we use that to graph our first problem, the y is squared, so that tells us it's horizontal. And remember this in the template, that part is our 4 times p. So p is -4 going to the left. And this is x minus h, so our vertex is at 3, and we take the opposite of that. So we started the vertex here at 3, -2. Now each tick mark on here is worth 2, so this is 3, -2. And remember, we go p units to the focus, and since p is negative, we go left, so 4 units left. 4 units to the right gives us the directrix. And then remember, our width is we go 2 times p, so I'm going 8 units up and 8 units down. So it's the same as we've done with the other ones. Our next problem is an ellipse. So again, our center is going to be the opposite of this, so -2, +3. Because both signs, both of these are positive and these numbers are different, it's an ellipse. And the bigger number is under the y, so it's vertical. Again, this is a squared, and this was the b squared. So a is 5, b is 4. We use the same formula we had before to calculate our c. So c is 3. So start at the center, so this is at -2, 3. And since it's vertical, we go a units, which was 5, up and down to get to the vertices, and we go b units right and left to get to our co-vertices, and we go c units up and down to get the, whoops, I didn't put the second focus, so I've got to go up 3 here, 1, 2, 3, and down 1, 2, 3, so our second focus would be right here. And I think I wrote these coordinates wrong, so it would be not here at 2, -2. That was the vertex. It's at 2, 0. So we have here 2, 6 and 2, 0. Now remember, when we did the first time around, we could write this in a shorthand notation using the plus or minus symbol. For here, we can't do that, so we've got to write each coordinate of each foci distinctly. Now we do a hyperbola. Again, the x is positive, so it's horizontal. Our center is at -2, 3. This is our a squared, because it's under the positive term. This is the b squared. And we have our formula c squared equals a squared plus b squared for hyperbola. So we get 6.4. So we start again at our center, so this point is -2, 3, and we're horizontal. So I'm going 4 units right and left to get to my vertex. I go 5 units up and down the B value to get the corners of my boxes and draw my asymptotes. So then I can fill in my horizontal hyperbola. And then we're going 6.4 units here right and left to get to our foci. And then we can determine the coordinates of those 2 points here. The next part of your assignment was to identify the rules for determining whether or how you determine a conic in quadratic form, what type it is. We've reviewed this in class, so I've just shown this here. And we had some problems here. So 3a was a circle because both the coefficients of the x squared and the y squared were the same sign, both plus 6 and minus 6, and the same number. 3b was a hyperbola because there were 2 terms squared, and the coefficients were opposite signs, one positive, one negative. 3c is an ellipse, both were squared and both were positive with different coefficients. And finally 3d was a parabola, only one of the terms was squared. Finally, we'll wrap up here with writing equations. So we were given a parabola with the vertex at 1, -2. So I showed the graph here. And the focus at 1, 1. So it wraps around the focus so we can see that it's vertical and going up. The distance from the vertex to the focus is our P. So that's 1, 2, 3 blocks. And it's going up, so it's positive. So we just plug into the right template. Since it's vertical, we want the x squared. So we put x minus h, so x minus 1, y minus k, so k was -2, and now here we have 4 times p, and we get this formula here that you can see. Here we have an ellipse, and we were given our vertices and foci, so I've shown them here. First time I did the problem, it didn't work out. We were going to have fractions for our center, so I changed these, and I just didn't feel like rewriting these. So you can see here, these are the points that are in the problem that you have. Now the center is going to be the midpoint between the 2 foci, or the midpoint between the 2 vertices. So the midpoint was right here, so that's the center, and also these are all lined up, so it's vertical. So this distance from the center to the vertex, that distance is our A, and this distance is our C. And we can use our formula here, c squared equals a squared minus b squared, to calculate b squared. And then we plug into our template, remembering it's x minus h and y minus k. And this, again, the center was, this is our h and our k. And finally, our hyperbola. The points given are lined up as shown here. So it's horizontal. Again, we do the midpoint of the 2 vertices, which is right here, is our center. And I wrote those coordinates over here. Remember, the distance from the center to a vertex is A, and the distance from a center all the way out to a foci is C. And again, we use our formula for our hyperbola, c squared equals a squared plus b squared, to determine our b squared. I had that formula here. And then plug into the formula. Since it's horizontal, the x term is squared. So I hope you did well on these problems, and if not, you might want to review these solutions, and we'll be practicing some more soon.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready?